this video, we calculate together the derivatives of these functions. We will use our table of elementary derivatives and the differentiation rules. Let's start from the first function. Observe that we can write it as 1/2 exponential of x plus 1/2 exponential of minus x. That is, as a linear combination of two functions, exponential of x, exponential of minus x, of coefficient 1/2. So, by linearity, the derivative y prime is equal to 1/2 the derivative of exponential of x plus 1/2 the derivative of exponential of minus x. So, the derivative of exponential of x is exponential of x plus 1/2. Now let's focus on the derivative of exponential of minus x, which can be read as a composition of functions. The internal function takes x to minus x, while the external function is the exponential. From the chain rule, the derivative is the derivative of the exponential evaluated in the internal function minus x, so exponential of minus x, times the derivative of the internal function, which is minus 1. So we obtain 1/2 times exponential of x minus exponential of minus x. In other words, exponential of x minus exponential of minus x divided by 2. We conclude by observing that the function y is, by definition, the hyperbolic cosine of x. While its derivative, y prime, is by definition the hyperbolic sine of x. We have thus proved the formula that appears in the table. The derivative of the hyperbolic cosine of x is the hyperbolic sine of x. The formula for the derivative of the hyperbolic sine is proved in similar way. Let's calculate the derivative of this sum of functions. By linearity, the derivative y prime is the derivative of the first function, sen square of x, plus 3 times the derivative of the second function, cosine of x squared, minus the derivative of the last function. We therefore need the derivative of sen square of x, which is a composition. Firstly, x is sent to sine of x, and then we take the square of the result. Let's call g the inner function. We can therefore calculate the derivative with the chain rule. The derivative of sen square of x is equal to g prime times the derivative of the power evaluated in g. So g prime times 2 times of g. That is 2 sine of x times cosine of x. Now, let's report the result. 2 sine of x, cosine of x. Now we need the derivative of cosine of x squared. This is also a composition. In fact, x is sent to x squared, and then the cosine. The internal function g is now x squared. From the chain rule, we have the derivative of cosine of x squared is g prime of x times the derivative of the cosine evaluated in g. That is minus sinus of g. Again, we substitute g and g prime and obtain minus sine of x squared times 2x. Bring it back to y prime, we have to multiply by 3, so we get minus 6 of x times sine of x squared. Finally, we need the derivative of the last function. This is an elementary function, and we can find its derivative in the table. It is, in fact, an exponential with base 2. So its derivative is 2x times natural logarithm of 2. And this is our result. Let's now consider this function. It's a composition. The internal function g sends x to the quotient. And then the inverse tangent function is applied to the result. To calculate the derivative, we use the chain rule. Y prime is equal to g prime times the derivative of the inverse tangent evaluated at g. That is 1 over 1 plus g squared of x. Now, let's focus on g prime. It is the derivative of a quotient, with the numerator equal to x and the denominator equal to x squared plus 1. Using the quotient rule, we have the derivative of the numerator, that is 1, times denominator, x squared plus 1, minus the numerator, x, times the derivative of the denominator, that is 2x, divided by the denominator, x squared plus 1, to the power 2. Doing the calculation, we have Let's now replace g and g prime in the formula. Here is our derivative. Let's consider the function x to sine of x. It is a function where both the basis and the exponent depend on x. To study function of this type, we use a trick, namely this identity. We can therefore write our function in this way, as exponential of natural logarithm of x to sine of x. Using the properties of the natural logarithm, we have sine of x logarithm of x. We are now ready to calculate the derivative with the chain rule. Indeed, we recognize the function as a composition, with the inner function g, which takes x to the sine of x, multiplied by natural logarithm of x, and the exponential function as the outer function. Thus, y prime is equal to g prime times the derivative of the exponential evaluated at g, which is exponential of g. Let's focus on g prime. Since g is the product sine of x times natural logarithm of x, we calculate its derivative with the Leibniz rule. So we have the derivative of the first function, sine of x, times the second function, plus the first function times the derivative of the second function. Replacing the derivative of the elementary function, we obtain this result. Now we can substitute in the formula for y prime. And we obtain exponential of sine of x times natural logarithm of x times cosine of x logarithm of x plus sine of x divided by x. We can also recognize the starting function in this term, which is equal to this, and so this. We can write the derivative as x sine of x times cosine of x logarithm of x plus sine of x divided by x. This is our result. Such a trick can be used with all the functions of the form y equal a of x to b of x, where both the basis and the exponent are function of x.